Hi, hello everyone. Today we are going to discuss, or rather, going to give a demonstration on a data science part. I'm going to show you how to do univariant, bivariant data analysis using a Premier dataset called Student Placement Record. I'm going to just show you the dataset first, which we received from a Premier B school in terms of the data that we received from them, which has various attributes. If you look at right from column B to column N, all these are all considered to be an independent variable or X variable, which help to determine the salary output. So basically, what the data says is all about the student of a Premier B school from a different stream, from different boards of school, and then in the MBA also they have a different specialization, and finally whether they placed or not, if they're not placed they won't get a salary. This is the fair idea that we got from this data set. Okay, now I wanted to do an end-to-end analysis about this data set, and I need to give an actionable insight to my management or a business person or my placement officer, whoever interested to learn the actionable insight. From that actionable insight, that they wanted to take a strategic decision in the following academic year, so that they can make sure that they can place all the students whoever studying in the final year or in the final semester of the MBA course in the following academic year. Okay, to begin the analysis, what I have done, I just gathered a couple of questionnaire. That questionnaire, which will help me to construct what I'm going to do with the data set, what I'm going to infer from the data set. All this thing I can do internally. That is part and parcel of data science. Once I gather those questionnaire, once I clear those questionnaire with Python script or any other tool, once I get a potential solution for those scripts for those questionnaire, I can go back to the business and give the actionable insight. From that, they can take a decision. Okay. So I will just show you the questionnaire what I prepared one by one in the Jupyter notebook along with the scripts, Python script. Okay. Now I just opened up a Jupyter notebook, which is an IDE useful to write Python codes. Now, first and foremost is that I'm downloading a library called Pandas, which is useful to analyze panel data, that is a tabular data. So the moment I download that, I can, meaning once I import that, I can use that Pandas package to read the CSV file, whatever we just saw in the CSV file. Okay, once I click, enter this, once I run that, I can see the same data, whatever there in the CSV. Okay, so this CSV file, which contains 215 rows and 15 columns. Okay. Now, what I feel, this serial number has nowhere related to any of these components which is available in the dataset. That is, it's neither has any connection with X variable, nor have any connection with the Y variable. Altogether, I feel I can reduce the data so that I can analyze, in crisp. So what I'm going to do, I'm going to remove a serial number from the dataset. So to do so, what I'm doing from the original dataset, I'm calling a function called a drop. In that drop function, I'm explaining or I'm mentioning which column I'm going to drop. Okay. In place equal to true is that since I'm not assigning into a variable, I'm assigning directly in the original dataset. That is why the reason I mentioned in place equal to true. Access equal to 1 is that whether I wanted to remove this column wise or row wise. If it is a row wise, I need to mention as access equal to 0. If it is a column wise, I need to mention it is access equal to 1. Having said that, I'm just running this script. Okay, now I'm querying the original data set. Let's see what is happening. Okay, okay, here is the difference. Now we have 215 rows and 14 columns, whereas in the previous one we had 215 rows and 15 columns. And in the previous one we had a serial number, and the latest one we no longer have serial number. Okay. Now what I'm going to do, once I remove the serial number from my data set, what I'm going to do, I need to make sure if at all my data set has any null value or a blank value. To do so, what I need to do, I need to write this script is null method with the sum, which will cumulate the null value, or I can use is NA method with the sum, so that is also give the same result. Okay, now if I execute this particular script, I'm getting all the values having no blank values except a salary. Okay, 67 record as blank value. Okay, I need to work on this blank value. I will have to remove this blank data, or I need to replace with a legitimate data. Okay, so as I told you previously, the moment I received a data set, first I need to make sure what is my data is all about. I need to bring in a lot of questions. Based on that question, I need to start analyze my data, so that I can make sure if at all I need to stop with just analysis alone, or if at all I need to run a machine learning algorithm to predict any future value. Okay, having said that, the first and foremost step is that I need to remove the NaN, that is non value. The expansion for NaN is not a number. Now I know that there are various mechanisms to remove the null value. First is that I can find out central tendency, that is mean median mode. I can replace with the null value, but that is not an optimal solution. The reason behind I'm not using that, if at all I use that, I may get some number, which means if I go back to the data set, I have this status and salary. If you look at status as placed, the student receiving salary. If you look at status equal to not placed, they are not receiving salary, hence it is blank. Okay, so there is a condition whenever a status is equal to placed, they are receiving salary. It is not equal to placed, then it is not receiving the salary. Having said that, having kept that in mind, what I'm doing, I'm not calculating using central tendency, because it gives some value which is adversely affect our analysis, because it will give a wrong approach that the student is not placed, still he is receiving some amount. Okay, so I'm not choosing that approach. Option B, I can remove this 67 record, but to be honest, if at all I'm receiving 67 records, it's not a advisable way of losing all this 67 odd student record, and working only with the student whoever placed in the campus interview. So that is also not a advisable approach. And the option 3 is that I can consider this as a semi-supervised learning. I can run a machine learning algorithm, and based on the input variable, right from a gender until status, I can predict the salary automatically. But that is also not an advisable approach, because that will give some X figure, any numerical number. So what kind of information that will give to the business is that the student is not placed, that is his status is not placed, still he is getting some salary. Okay, that is also giving a wrong notion to the business. Therefore, what I'm doing, I'm taking an approach of replacing all the non value with 0. Okay, if I do that, I will be satisfying three condition. One is that blank value is replaced with some value. Second is that I made it as a quantitative data. Third is that the meaning of that particular data has not been changed. Even I keep it as a zero or blank, the student is not placed. That's why the reason they are not earning. So the meaning of that data has not been changed. So based upon the business scenario, based upon the data set, we can come to this particular decision, and we can choose either of the option. In this standpoint, I plan to choose replacing with 0. That is the optimal solution with respect to this particular situation. Now what I'm going to do, I'm going to replace with the 0. To do so, what I'm doing, I'm calling the original data set, only the salary column which had not a number. Wherever I had not a number, I'm replacing with the 0. In place equal to true, as I told you, I'm just changing this in the original data set. Once I execute that, okay, what would happen? I will just show you something more here. Okay, what I'm doing, I'm just going to uh, run the original data set. Okay, now if you see this status not placed, salary has become 000, meaning the literal meaning of that particular data set has not been changed. Still they are not placed, they are just receiving 0 salary. Okay, to make sure that none of the fields are having null value, I'm just running the script once again. Now I'm no longer able to see 67, whereas when I was executing this particular command before we are replacing with the 0, I was getting 67. Okay, now the 67 is completely wiped off because we replaced with a 0. That is the first and foremost stage where we convert not a number blank value into a 0. The next question that I had in my mind is that how many of them not placed versus how many of them placed. Okay, when I try to write this particular query, I will be able to identify how many of them are placed. The true stands for 67, have not been placed, 148 have been successfully placed. Okay, and the next question that I had in my mind is that to find the reason for not placement, because there could be a number of reason for the student not being placed unless I speak to the placement director or placement consultant. I may not able to understand what is the reason behind the students has not been placed. Despite the fact, what I can do complete exploratory data analysis so that I can identify the relationship between the data, and I can narrate the story, the reason behind the student have not been placed. So what I have done, I just created a central tendency quartile concept, that is 25, 50, 75, and also I created 1.5 IQ or standards. Everything I just executed, and finally got this result table. From this I was able to identify and able to tell to the placement officer that recruiter may not be interested with the student whoever secured between 56 to 65% right from 10th standard to MBA. Okay, and similarly, if they take first quartile of the data set, which fall within the range of 57 to 60, which is not a potential attract to the recruiter. And thirdly, minimum pass percentage mark is also not attracted by the recruiter, which is between 40 to 51 percent, right from 10th standard to MBA. Okay, from this analysis, I was able to tell the reason behind the student not placed is this three reason. Okay, now I need to tell you how did I arrive this particular solution, how did I created this particular table. To do so, first I will have to do analysis of the data. What I'm doing, I'm just calling the inbuilt function called a describe from the original data set, so that I can get this table something like this. Okay, but this particular data set is giving count, mean, standard deviation, but I'm not able to see median, mode, variance, skewness, then min value, and so on. So what I'm planning to do, I need to create a custom table. In that custom table, I need to create some kind of a logic. Using that logic, I need to pull in the original data set and mix up with the logic, and I can place with the custom table so that I can query my custom table and get to know the facts. So to do so, what I'm going to do, I'm going to just downloading or importing this particular package called a NumPy, which is a numerical Python. This is useful to calculate percentiles. Okay, Q1, Q2, Q3. So that is predominantly done using a NumPy package. Now what I have done, I just created a custom table called a unique table. In this custom table, I call up a library called a PD, which is a pandas. Okay, which we already called up with the alias name as PD. Okay. With that custom table, I'm also calling a method called a data frame. In that data frame, I'm creating index. In that index, I'm just listing out what are all the column that I expected to see. Now I need mean, median, mode, first quartile, second quartile, third quartile, min, max, interquartile range, 1.5 interquartile range, lesser and greater. Okay, and apart from that, I need to compare this with the original data set with the quantitative data, because this data set has both the quantitative and qualitative data. This statistics is applicable only for a quantitative data, and it won't be applicable for a qualitative data. So what I've done already, I just segregated quantitative data from the qualitative data. So to show you that what I have done here, I created one function called def conqual. In that def conqual, I just created one function. In that one function, I called up for statement. Using for statement, I'm iterating using column name in the data set. Okay, so whichever is falling under the object called O, which are all considered to be a qualitative data which need to be appended into the qual list. So whichever fall under integer or float or not equal to object, not equal to categorical data that fall under quantitative, that will be appended into the quantitative list. Okay, and returning that into the qual quan variable. Now I just calling the conqual variable. Once I call up a conqual variable, I will be able to clearly segregate what and all goes to quan, what and all goes to call. Okay, these are all quantitative because this deals with numerical, and right from gender until status, all these are all part of categorical variables. Okay, since I have created this particular function, so what I have done, I just call up that particular quan list, okay, which consists of all the numerical variable from the data set. Now I'm creating for loop. In that for loop, I have a temporary variable. Using this temporary variable from the quan, I'm iterating one after the other. In the unique table, I'm calling the first column. Okay. In the first column, I'm having a mean. Okay. That is in the first column, I have a mean. This entire row, I need to calculate mean. So what I'm doing, column name, which is I used a temporary variable as column name, QUN, which is a quantitative variable. This will take one after the other, and it will consider the mean index. In that mean index, it will take the original data set, and we use mean method to calculate the mean. So once I done that, this mean row which will be filled up with the mean values. Okay. Similarly, I can do it for median, mode, and when it comes to percentile, I will have to call up NumPy packages. Using NumPy packages, I can clearly call out 25, 50%, 75% quartiles. Okay. After that, I can identify what is the minimum range, what is the maximum range, and also I can calculate interquartile range. In the interquartile range, the formula is that basically it's Q3 minus Q1. Okay. So that is the interquartile range formula. Once we get the interquartile range, I will have to multiply with 1.5. That is the industry standard calculation to identify the max and the min outlier. Okay. So when we had a minimum outlier, so what we have to do from the first quartile, we will have to subtract it with the 1.5 into IQR. When you have maximum outlier, which is goes beyond Q3, what we have to do, we have to add it with the interquartile range, whatever we found out from this formula. So this formula you will have to write it in a piece of paper before you keep your hands into this Jupyter notebook, so that you can easily create this particular script. Okay, once you publish this, you will get a result something like this. Okay, now what I need to understand, I need to identify the outlier from my data set, whether it is present. If it is present, I will have to replace that with the IQR value for both min and max. So what I'm trying to do, I'm creating one logic here. Okay. If you look at this particular row, we have a lesser and we have a minimum. So this minimum should not be should be less than this lesser. Okay. In case if it is beyond this, what you have to do, we have to replace it with the lesser value. Suppose, for example, in this case, we have minimum 40, whereas here it's 37.95. So we don't have to call up because this is beyond the lesser. This one is less than lesser. So we will have to call up this value, which is fall under 12th standard pass mark. Okay. And thirdly, degree pass mark 50 and it is 45. So we don't have to call up. 50, 25, we don't have to, because this is beyond 24, this is beyond 45. So we don't have to call up. So if it is just 4-5 columns, you can manually get that calculated. In case if you have 1,000, 2,000, 5,000 columns, then you don't have to do that manually. Rather it's a time consuming process. What you have to do, you have to just write the script something like this. What I have done here, I'm just creating an empty list for lesser and created a empty list for greater. Now I'm just iterating using a for loop, using temporary variable column name and iterating in the unit table which we have created here. And in the unit table column, I'm taking this minimum value. If this minimum value is lesser than this lesser row, just append it in the lesser list. Similarly, I'm taking a unit table maximum row and comparing with the greater. When this maximum value is greater than this greater row, then put it in this greater list. Okay. Now for minimum, we identified we will be getting 37. Okay, that is we will be getting a higher secondary pass mark for lesser. And similarly, when we calculate for greater, when we compare maximum with the greater, it is just as 89 when compared to 96, 98. So we can leave this 97. Okay, it's greater. We can take a higher secondary pass. 91 with 88, it's greater than 88. So we have to take a degree pass mark. This is less than 118. This is less than 78. This is greater than 70,000. So we need to take higher secondary pass, degree, and a salary. Okay. Now we execute this particular lesser list so that I can get to only higher secondary pass. Okay. Similarly, if I execute greater, I will be getting higher secondary pass, degree, and salary. Okay. Okay. Which means all this having outlier. Okay. This has minimum range and this has a maximum range. Now we are going to replace the outlier with the value what we have found out using IQR. In the OQR, we identified a lesser and a greater. Okay. Now what we are trying to do, we are just using the for statement and iterating with this lesser and another for loop with this greater. Now we are taking the original data set, each column. In the original data set, each column need to compare with the temporary table, that is a unique table. Okay. All column lesser. Okay. That is the original data set. Every column name in the original data set, what I'm doing, I'm calling the original data set. In the original data set, I'm taking the original data set column and comparing with the lesser value which we identified as a part of this unique table. If it is less than the lesser value which is there in the unique table, just replace it with that lesser value whatever we found out in the lesser table. And similarly, it's applicable for greater also. Take the original data set, that is the data set data points, and go to the data set all column. If all column is greater than the value that is there in the greater column, replace with the greater value whatever we show in the table. That is what we are doing here. Now what I'm going to do, I'm going to just execute the query here. Once I execute that, okay, what I'm going to do, I'm going to run the same unique table once again so that the calculation, everything will be reconciled. Once I done that, what happened? Now, if you look at the lesser, we had a 42.75, which has automatically got replaced with the minimum value. If you look at the greater, we had a 91.15, which has been replaced, 88.5 replaced, 70 something replaced with salary. Okay, this is how we need to replace the none value with either lesser or greater. It depends upon the kind of extreme value that you see either in the first quartile or beyond the third quartile. It's up to you the way that you see the data. Okay. Now I'm just running the query once again. Okay. Now I see less as empty loop because nothing is outlier present. Greater is also empty loop, empty array because all the extreme values have been replaced with the lesser or greater array respectively. Okay. This is how we need to find out the extreme or outlier and replace it accordingly. This is already we discussed the way to segregate quantitative and qualitative data, and this has been kept under the function because I don't have to write the code from scratch. Moving forward, if at all I wanted to analyze quantitative and qualitative data, I can just call up this particular function and I can execute so that the time, energy, everything will be reduced a lot. Okay. Once I run this, I'll be getting on top of greater, I'll be getting a skewness, kurtosis, variance, standard deviation, everything. You can just see from this one table. Everything is like a one-stop shop for you. Okay. And this is table useful for me to give an additional justification. This is basically a frequency table. In this frequency table, I can rationalize my decision because I have a unique value, 62%. 62% being received by 11 candidates, 63 just 10. As the percentage of marks is keep going up, the frequency is getting reduced. Okay, that is beyond 75%. The frequency is just one or other two. Okay, so this kind of an insight that I received from this particular frequency table. So after that, question number 3, what kind of relationship between salary and MBA pass mark? So I would say that 14% would be the relationship between MBA pass mark and the salary. It is positively correlated. However, the degree of freedom that we can exactly tell is a positive is not up to the mark because it's just just positive, or rather neither called as a positive nor called as a zero. It's in between the line. So to execute this correlation, we can identify the relationship between MBA pass mark and the salary, which gives me just 14%. Okay. And moving on next, which specialization is getting minimum salary? Okay. Okay, here is a catch. Before you run or you cleanse the data, replace NAN with a zero. If you run this particular script, you will be getting a minimum salary of 2 lakh for both marketing, HR, and marketing finance specialization. Since I have replaced the data with zero, whichever had NAN, now you will be getting zeros for both both the specialization. Okay, so if at all you wanted to know about why are you getting a zero, why can't we get a 2, what you have to do, you have to run this script before running the query to replace NaN with a 0, otherwise you'll be getting 0. Okay, so how many of them getting above 5 lakhs? So from this query, I would be able to identify that 3 people are getting beyond 5 lakhs. So this is just, I'm passing an empty list. In this empty list, I'm using a for loop. I'm calling this temporary variable I, and then passing on to the original data set salary. If my temporary variable, which will, take into consideration only quantitative, values from salary, which is greater than 5,000, just append it in my empty list, which is above 5L empty list, and print that, so that I can get an answer that these 3 people are getting a 3 lakh salary. Okay, even if you put length, you will get the length, like how many people are getting. Okay, and the 7th question is that we need to do an analysis of variance between entrance test and MBA pass mark at a significance level of 5. So this can be justified using hypothesis testing. So before I submit my hypothesis, I will have to let you know that HO stands for null hypothesis and H1 stands for alternate hypothesis. HO, as I told you, null hypothesis, there is no difference between entrance test and MBA pass mark. Null hypothesis H1 states that there is a difference between entrance test pass mark and MBA pass mark. And we have a standardized rule that if p-value is less than 5%, just reject null hypothesis. Now I'm going to execute one-line classification so that I can identify the actual result, what is happening. Okay, if you look at the stats value, I got 98.5%, which is closely 99. So there is a good amount of differentiation between test and MBA pass mark. Okay. And when you look at the p-value, which has got 4.67, which is less than 0.05, therefore, what I'm going to do, I'm going to reject a null hypothesis and I'm going to accept alternate hypothesis, which is H1 in this case. Okay, which means there is a difference between MBA pass mark and entrance test pass mark. Okay. Moving on to the next question, eighth one, test the similarity between degree stream, that is science and technology, and specialization marketing HR with respect to salary at a significance level of 5. Here also I need to do an hypothesis testing to state my argument. So here the null hypothesis HO stands as there is no similarity between a degree stream, that is science and technology, and the specialization marketing and HR with respect to salary. H1 alternate hypothesis says there is a similarity between the degree science and technology and the specialization marketing and HR with respect to salary. As I told you previously, that we globalize the concept that reject the null hypothesis when it is less than 5%. Now, what I'm going to do, I'm just going to execute this particular query as a part of one-way classification. When I do so, I got a stats of 2.69%, which is pretty much similar. There is a similarity between the degree that is science and technology with respect to salary, and specialization marketing and HR with respect to salary. And the p-value is just giving a 0.00, which is less than 5%. So I'm rejecting a null hypothesis and accepting alternate hypothesis in this case. Moving on to the ninth one, which is a very good question. Basically, I need to identify the normal distribution for salary column, because salary is our criteria, which is an output variable. So I'm just running this particular script to get a normal distribution curve for salary. Okay, this is my normal distribution curve for salary. If you look at this particular code, I just created one function called norm. I'm inputting my data set. Import.cbound is useful to go draw a graph. I'm calling that cbound library distribution plot. In that, I'm calling my original data set. KDE kernel distribution equation equal to true, which will form this graph. Okay. And I'm giving it should be a normal distribution of data set from the column salary, because I need to calculate only for salary. That's why the reason I gave the input as salary. The moment I enter this, I'm able to see the normal distribution. Forget about the X values. It starts from minus 2 lakh and keep on going to 2 plus somewhere around 9 lakh. Okay. Initially, it starts with minus 2 lakh and it goes 0, and there is some ups and downs and keep going on. Now, what I have to do, I'm planning to convert that normal distribution into the standard normal distribution, so that I can identify whether the same information able to see in the standard normal distribution. Okay, the reason behind I'm do that, we have a famous concept called a standard scalar, where we need to convert the data into one particular range, right from -1 to +1, right from +2 to -2 to +2. Within that range, we will be bringing in the data. However, the behavior data pattern will not be changed. We will be getting the same remarks, actionable insight from the same graph what we did see in the normal distribution. So to execute this, once I execute that, I got the same graph, same line, everything. Only the data points, it starts from -2 until it goes 4. Okay. So this is useful for standardizing the data set when you are doing a machine learning algorithm. When you have a data set like which has a maximum value, when you have a maximum value direct with a minimum value, when you get a huge differences, you may not able to work with the data set. At the moment you work with the data set, when you get an output, it may not give a pure actionable insight based upon the data pattern. So what you can do, you can just use the standard scalar and convert that extreme values into the standards, like from -1 to +1, -2 to +2, or -3 to +3, so that information remain unchanged. The metrics alone be changed. Okay. The next question is that we need to find out the probability density function of a salary between 7 lakh to 9 lakh. Okay. போய் தொலைங்கடா அந்த பக்கம். Okay, now what I'm going to do, I need to identify the probability density function for the salary column within the range of 7 lakhs to 9 lakhs. To identify that, I need to give it in a pictorial or in a graphical way. So what I will be doing, I'm just creating one function called get PDFP. Okay, I'm just getting input from the user, that is starting range and end range. I'm calling the necessary library, which is matplotlib, statistical, Python, SciPy, Seaborn. Okay. Now what I'm doing, I'm creating one variable. In that variable, I'm calling a Seaborn package. In that Seaborn package, I'm using a distribution plot. And distribution plot, I'm calling the original data set. As I told you, kernel distribution equation equal to true gives the graphical representation. And the kernel distribution equation KWS will give the layer on top of that bar graph. That layer can be defined using the custom color. I just specified blue color. You can specify any color, and the background color, that is the bar original bar color, should be in purple. Okay. I'm just getting a red, which is an user inputable line. Using that line, I'm able to tell from which line to which line. In this case, I'm taking 7 lakhs to 9 lakhs. That is the start range and end range as a part of user input. So getting that input and calculating the range. Okay. Let me just run this particular query so that you will be easily correlate with the output. Okay. So I just executed this. As it run, we will discuss about the rest of the items. So what we are trying to do here, we are just assigning the original data set into the sample, and we found out mean and standard deviation. And the mean and standard deviation would be printed here. And we called up within the normal distribution function, so that from that mean and standard deviation, we got the normal distribution. Okay, after that, we are creating one empty list called values. So with that empty list, what I'm doing, I'm iterating using a for loop, using this temporary variable called a value. I'm calling each value based upon the user input from starting range to end range. Here the starting range is 7 lakh and the end range is 8 lakh and 90,000. It will not consider 99 lakhs. Okay. And then it will just append in the empty list. Okay, that's why the reason I put append in the empty list as val. Val is that temporary variable. Then what we are doing, we are creating one more empty list called probability. I mean, again using a for loop, and I'm bringing in a value is a temporary variable. In values, in the values right now, we have 7 lakhs until 8 lakh 90,000. First, it will take the 7 lakhs and keep it here, and then it will go to the append. When it is append, it will just read this function, the distribution dot PDF probability density function value. So automatically it will calculate what is the probability density function for 7 lakh. Similarly, it will iterate for each and every figures until it reaches 8 lakh 90,000. Okay. Now what I'm going to do, I'm going to sum up all the probability, whatever we discovered here. Okay. That's why the reason I put it as prob equal to sum equal to probability. Now I'm just going to print the start value, which has been inputted by the user, and the end value and the sum of this value, and returning to the prop. Okay. So since I created this as a function, I'm just calling this function get PDF underscore P. I know the data set and which column I need to do this for. So I'm just inputting a salary, which is more the column against which I need to identify the probability density function between the salary range of 7 lakhs to 9 lakhs. Once I input everything, I'll be getting a graph something like this. As I told you, right, based on the input, the red color will be formed. As I told you here, I inputted 7 lakh to 9 lakh. I got the range between 7 lakh to 9 lakh. AX is that axis, V stands for vertical. Okay, now it's in vertical. Okay, that's why it shows vertically. And after that, standard mean and standard deviation we calculated, and we passed on into the normal distribution variable. So it created this thing, and it calculated mean and the standard deviation separately. Okay, and finally we inputted what is the start and end range, and what is the sum of probability. We got this. The range is 7 lakh and 90 lakh, and the sum of the probability is that 0.00 something. Okay, so this is how we identify the probability distribution function between the salary range of 7 lakh to 9 lakh. Okay, moving on, next question. Test the similarity between the degree, that is the specialization science and technology, with respect to entrance test mark and MBA pass mark at a significance level of 5%. Make hypothesis testing. Okay, so in this hypothesis testing, HO, that is null, stands for there is no similarity between degree science and technology with respect to entrance test pass mark and MBA pass mark. Null hypothesis reject the alternate hypothesis reject the null hypothesis, and it says there is a similarity between degree science and technology with respect to entrance test pass mark and MBA pass mark. Okay, now we globalize the concept, reject null hypothesis if the p-value is less than 5%. Okay, now I'm just executing this online or one-way classification. Once I done that, the statistics value, it shows 4.5. So more or less, it is pretty much significantly the similarity can be identified between the degree, that is science and technology, with respect to entrance pass mark and MBA pass mark. And if you look at the p-value, which is just 1.42, this is less than 0.05. Therefore, we are rejecting the null hypothesis and accepting alternate hypothesis in this case. Okay. And moving on, next question, which parameter is highly correlated? Okay. Now I just execute this query. Correlation. Correlation is that we identify the relationship between any two variables. So here I wanted to understand the correlation, meaning like I wanted to analyze from the data set in the salary which column is give high level of correlation. So when I compare all these columns with the salary, I can see a 10 standard mark which is giving a good amount of correlation with respect to salary, which is somewhere around 55%. Whereas 12 standard degree pass mark entrance and all, though it is correlated, but is not to an extent of 10 standard pass mark. Okay. Now I just wanted to plot this as a graph so that my placement officer don't have to scan through all this text. Maybe his brain got switched off if at all he is seeing all these data points in black and white. So what I would prefer, I would like to call up a heat map so that I can clearly tell what is what. Okay. Now what I'm doing here, I'm importing a Seaborn library, matplotlib, to plot my graph, and I'm calling the heat map variable. So I'm calling the Seaborn library. In the Seaborn library, I have a heat map method. In that method, I'm calling DD. DD is nothing but the correlation, whatever we created here. And another true is that on top of every cells, the graph itself explains about the data points. So you don't have to manually explain because graph is itself is a self-explanatory. Okay. And next is that I'm trying to give a title to the graph, okay, which is a correlation matrix of student placement data set. And finally, I'm showing that particular graph in a heat map way. So the moment I execute that, you will be able to see the graph something like this. Okay. So if you look at this data point, 10 standard pass mark and a salary, which is 0.56%, that is 56%. Okay, when you compare any of the data set, it is just less than 56%. Okay, And even if you look at this side also, 10 standard and salary, it's point, I would say 56%. Okay. So this will give a clear picture to the uh, placement officer or the person whoever handed over this project, that the correlation between any variable with respect to salary is the highly correlated value is that the 10 standard pass mark. I'm not able to only say through the black and white of text. I can even vouch using my graphical representation, so that they can easily understand and even they can share internally and come to a consensus, so that they will make sure that they wanted to take a better decision in the following academic year, and they can reduce this 67 non-placed students as low as possible. So this kind of actionable insight, which will definitely help the B school to strategize themselves and place more candidates in the following academic year. Hope this particular data science univariant bivariant analysis and with a few graph help you understand the concept. Stay tuned on my YouTube video to listen more videos. uh, Thanks for listening my video. Have a wonderful day ahead. See you. Bye bye.